Hello everyone, this is Martha from the Academic Support Center, and this is the start of a series of videos where we're going to go over some Calculus 1 final review problems. Alright, to get us started, our first question is to evaluate the following limits. So we're going to start with A. And the equation is x squared minus 4x plus 3 all over x minus 3, and it's the limit as x goes to 3. If we put in direct substitution, then we're going to have a 0 in the denominator. So let's see what we can do. So for starters, let's see if we can factor this numerator. What numbers multiply to positive 3 but add up to negative 4? If we do x minus 1 and x minus 3, that is the factored form of our numerator, x minus 3. And we can see that we have two x minus 3's, everything's being multiplied, and so we are just left with the limit as x goes to 3 of x minus 1. Now we can use direct substitution. We put 3 in for x, and our answer is 3 minus 1, or the limit is 2. Now let's try B. This one has a lot of square roots, and oftentimes when we get that square root like this with a plus or minus in between, we can use a conjugate pair. So we're evaluating the limit as x goes to 0 of square root 3 plus x minus square root 3 all over x. Well, if we do direct substitution, it's not going to, we're going to have a 0 in the denominator, so it's not going to work. But if we multiply top and bottom by the conjugate pair being the square root 3 plus x plus square root 3, we're just multiplying the equation by 0, or by 1, sorry. 3 plus x plus square root 3. And we're just changing the way that it looks. I'm going to start with the denominator and keep that the same. We have x, the quantity x, times 3 plus x square rooted plus square root 3. Now let's FOIL the top. Square root 3 plus x times square root 3 plus x results in 3 plus x because it's the same quantity squared. And then, FOILing it out, the first and the last, we get plus square root 3 times square root 3 plus x. Now, FOILing the middle, we get minus square root 3 times square root 3 plus x. And then the last term, minus square root of 3 times square root of 3 is 3. We can do a little bit of cleaning up because we have a plus one quantity minus that quantity, so it's going to go away. And we also have a plus 3 and a minus 3, so those will cancel out. Ultimately, what we're left with is x over x times the quantity 3 plus x plus square root 3. And remember, so we're taking the limit as x goes to 0. We can cancel out an x and an x because everything's being multiplied, and we're left with 1 over this. Now, if we put direct substitution in, or if we use direct substitution here, that works. We have 1 over, putting our 0 in for x, 3 plus 0 plus square root 3. Well, 3 plus 0 is just square root 3, and so we have square root 3 plus square root 3. We're left with 1, 2, square root 3. And that's the limit as x goes to 0. Now let's give C a try. Whew, this one looks fun. So we have the limit as x goes to 2 of 1 half minus 1 over x all over x minus 2. Well, let's see what we can do. If we get let's put the numerator in with a common denominator. So we multiply 1/2 by x over x, and then 1 over x by 2 over 2. If we do this, we have a common denominator of 2x, and then 1 times x is x, 1 times 2 is 2, we have x minus 2, all over x minus 2. And if we do the keep, change, flip, or multiply by the reciprocal, we've got x minus 2 all over 2x times 1 over x minus 2. Now everything is a quantity that's being multiplied, so we can get rid of those, and we have 1 over 2x. And we're taking the limit here, and the limit specifically as it goes to 2, so we can do direct substitution here. We have 1 over 2 times 2, or 1 over 4. Making pretty good progress here. So let's do the limit as x approaches 0 of sine x over 2 sine x. So we've got, now what would happen if we were to put direct substitution in here? We would have the form of 0 over 0, which is an indeterminate form. So we've got a great rule that can help us out here, and that's L'Hopital's. And that says that if we take the derivative of the top and the bottom, we can solve for things. So the derivative of sine is cosine, and the derivative of sine 2x, remember we've got a chain rule here, so it's 2 sine 2x, or oops, cosine. That's cosine because we're taking the derivative. Now here, if we go back and do direct substitution, the cosine of 0 is 1. We end up with 1 over 2 times 1, or 1/2. So for the last two, we had to clear some space. Let's look at e now. We've got the limit as x approaches 0 of tangent 3x divided by tangent 4x. Now this is one where if we were to do direct substitution, we would have an indeterminate form. And so we can use L'Hopital's rule by taking the derivative of the top and the bottom. Tangent luckily has a nice clean derivative. The derivative of tangent is secant squared. Secant squared of 3x over, times 3 because of the chain rule. Can't forget that. Multiply by the derivative of the inner. Secant squared times 4x, or times secant squared of 4x times 4. There we go. Now, if we use direct substitution, we have secant squared of 0 for both the top and the bottom. And we have secant is 1 over cosine. And the cosine of 0 is 1. So we end up with 1 over 1 squared, or just 1. So we're multiplying 3 times 1 and 4 times 1 to get the answer of 3/4. Now for f, for the next one, this, if we remember a property of limits, this can really make this a lot easier. We've got the limit as x approaches 0 of sine of x over x, or either form x over sine of x. That equals 0, or that equals 1. And this is a property that holds. So going forward, let's see how this can help us in our problem. We've got the limit of sine squared of 2x over x squared, and it's the limit as x approaches 0. Now if we break this down, just making it look different can help us. if we break this down into one thing multiplied by another, it's the limit as x approaches 0 of sine 2x over x times sine 2x over x. And this can really help us out. We can take the limit of each piece and multiply it together. There is something that we need to do before though. We need this 2x to match top and bottom. So if we multiply each thing by, or each term by 2 over 2, we're just multiplying by 1. But our result is the limit as x approaches 0 of 2 sine 2x over 2x times the limit of 2 sine 2x over 2x. We're almost there. Because this 2 is a constant in both cases, we can put it, using the properties of limits, we can put it outside. And we're left with 2 times the limit as x approaches 0 of sine 2x over 2x times 2 times the limit as x approaches 0 of sine 2x over 2x. And what we've done is we've made our life a lot easier because we can know that this limit right here of the limit of sine as x approaches 0 of sine of 2x over 2x, that equals 1. And the same for the second term, the limit as x approaches 0 of sine of 2x over 2x, that equals 1. And we end up with 2 times 1 times 2 times 1, or 2 times 2, meaning 4, that the limit is 4.